Hello, Algebra. Today we are going to do day 3. Again, focusing on skills that we need to be able to factor. Okay. The top of the page should look pretty familiar, recognizing perfect squares. The last unit that we did, we kept writing perfect squares down on our paper just so we would get familiar with seeing them. Okay, so let's take a look. As I'm talking, you should be thinking like one step ahead of me. Is 36 a perfect square? Hopefully you think yes, because the square root of 36 is 6. Is 54 a perfect square? It is not a perfect square. Is x squared a perfect square? Okay, so we've got a variable and we're wondering if it's a perfect square. The answer here is yes, because if I were to take the square root of x squared, the fact that that's an even exponent means I would just cut it in half and I would be left with simply x. I would have no square root left. The fact that it's an odd exponent in D means no, it's not a perfect square. 27x cubed, now I'm putting them together. Okay, this is not a perfect square for two reasons. 27 is not a perfect square, and x cubed is not a perfect square. They both have to be perfect squares in order for me to say that that whole term is a perfect square. Like in f, this whole term is a perfect square because 100 is a perfect square and because x squared is a perfect square. If I were to take the square root, I would get 10x. 9x to the fourth, yep, because the square root of 9 is 3 and the square root of x to the fourth is x squared. 4/9 x to the sixth, now I've got a fraction here, but the answer is yes, because both 4 and 9 are perfect squares. That's going to leave me with 2/3, and then 6 is an even exponent, so I can just cut it in half. All right, so that will be a skill we will need for one of the types of factoring we will do. Create an X box for the equation below. Okay, here we go. Oops, let me go back to my pen. Boop, boop. A times C is positive 24. My B value is positive 10. Okay, here's where I would go to my calculator, and I want you guys to do the same. So if you need to pause the video to go grab your calculator, do that. Everybody should be going to y equals, and we should be typing in 24 divided by x. Okay, we're going to hit second graph. We should be super familiar with this. We should be starting at 1, so my table looks like 124, 212, 3, 8, 4, 6, and so on. And now we're not just looking for perfect squares like we were last unit. We're looking for any numbers that go into it nicely, okay? I'm going to write down what I'm looking at. I wouldn't normally do this part if we were in class because you could see the board. Okay, I just had to move my screen over to make a little bit more room. Here's what I'm looking at in the calculator. 124. That means 1 times 24 equals 24. 2 times 12 equals 24. 3 times 8 equals 24. 4 times 6 equals 24. 5 and 4.8, I'm not putting that one in because that's a decimal. Those numbers don't go into it evenly. 6 and 4 I already have on the list. So here's all my factors. This is what the table helps us with, is to get all our factors. So I'm looking at those, and I want the two numbers that multiply to 24. That's all of them. So they all fit that bill. But now I need to pick the pair that's going to add to a positive 10. When everything's positive, this is a little bit easier. 4 and 6 are my numbers that I need here. Okay, you guys try B. Pause the video, because I'm going to move on. Pause the video. Try B on your own, and then come back and see if you did it correctly. Okay, hopefully you paused the video and tried that. I'm in the calculator. I'm just putting in 15 divided by x. It gets way too confusing to look at all the positives and negatives. So just put in a positive. We can figure out the negatives as we go. So looking at my table, 115, 2 has a decimal next to it, 3, 5 is a good one, and then the next one I see is 5, 3, which is the same as that. So these are my only options. Which of those is going to get me a positive 2? Well, it's certainly not going to be 115. There's no way to get a 2 out of that. 3 and 5 is looking good. So now my choices are -3, +5, or -5, +3. They have to be opposite signs because I have to get a negative 15. Oops, I meant to do the highlighter there. They have to be opposite signs. And then in order to get a positive 2, I have to make sure the 5 is positive and the 3 is negative. And then I like to always double check in my head and go, okay, negative 5 times positive 3 is certainly going to get me that negative 15. And negative 5 plus negative 3 is going to end up being a positive 2. Okay. All right, working backwards here. You guys can pause the video and try these two. We should be pretty good at these at this point because we have been leading up to this. Go ahead and pause and try them on your own, and then come back and check and see if you got them. All right, I'm going to continue on here. If I have a 6x squared in the middle, this is going to have to be a 2, and I need an x there. What do I multiply by 3 to get 27? That's going to be 9. I need to make sure I put a plus here. And I don't need an x in that case because it already has an x on the outside for the 3x. Okay, moving over to B. I like to start right here at the top. If I already have a 2, this just needs to be an x. You can put 1x if you want. But 2 times 1 is 2. X times x is x squared. Over here, this is just going to be a 1 because when this is identical to this, that means I'm just multiplying it by 1. Down at the bottom, that's going to be a negative 3. X times negative 3 is negative 3x, and then I double check. Negative 3 times 1 equals negative 3. Yep, that looks good. Let me see what I put in the directions. Find the missing dimensions of the boxes by working backwards. Express your answer as a product of two factors. Okay, I skipped that step, so I want to go back and do that. Here's what I mean, express my answer by as a product. 3x times, product means multiplication, 2x plus 9. There's two factors, 3x and 2x plus 9. Whatever's multiplied together are the factors, the outside of the box. In this case, I'm going to have 2x minus 3 times x plus 1. There we go. All right, find the GCF. Here we go. So here's where the calculator can help if you struggle with finding the GCF. GCF means the biggest number that goes into both of those. Now we're going to bring variables into it as well. But it will help me with finding the GCF of the numbers. Like 3 is the biggest number that goes into both 6 and 9. If you struggle with that, or if those numbers are a lot bigger and it becomes harder to do, this is where we can go to math on the calculator, over to num, which is just for number, and choice 9 gives us the GCD, which is the same thing as the GCF, and we would put in 6, 9. If we do that in our calculator, it will tell us 3. Okay? Boop. Now, when it comes to the variables, if they both have the same letter or variable, then it definitely goes in our answer. And then we take the smaller of the two exponents. Okay? They both have x's. X squared is the smaller one. They both have y's. Y to the first is the smaller one. Okay, between 25 and 5, 5 is the GCF. They both have x's. X to the fourth is the smaller one. The reason we have to take the smaller one, even though this says greatest, is because x to the fourth goes into x to the sixth. Okay? But x to the sixth does not go into x to the fourth. We're looking for the most amount of x's that goes into both of them. X to the fourth goes into both of those. Once we start getting higher than x to the fourth, it doesn't go into that one evenly. Okay, C. Okay, 32 and 48, this might be a place where it would be useful for you to use your calculator. So, following along, I'm going to say the steps out loud. We're going to go to math. Math is the button that is right below alpha. We're going to click over to num, and then it's going to be choice 9. And you could just hit 9. In your calculator, it should show up like this. We're going to put in 32. Don't forget your comma. 32, your comma, and then 48. The GCF is 16. Okay? They both have A's, so I'll put an A there. Squared is the lowest exponent. They both have B's. Squared is the lowest exponent. And that is how we find a GCF. Okay, if you have the following skills, you are ready to start factoring. Finding a GCF of numbers and variables. We just did it. Creating an X diagram. We just did that above. Working backwards to fill in the outside of the box. Check. Identifying terms that are perfect squares and take the square root. All right, let's start factoring. We're moving to the next page. Okay, to factor means to write one expression as a product of its factors. Product of its factors. Okay, here we go. Recall. The area of a rectangle is 5a squared minus 15a. If its width is the GCF of the area, find the other dimension of the rectangle. Okay, so here's what we're going to do. Remember, area is going to go inside our box, so 5a squared minus 15a. The outside of the box is going to represent our length and width. So right here, we need to find the GCF of both of those terms. Okay, so what is the GCF between 5 and 15? We're not going to worry about the sign, it being negative. We just need to think about both of those numbers, 5 and 15. The GCF is 5. You can use your calculator to find that. If you can do that in your head, awesome. They both have A's, so there will be an A in our GCF. The highest exponent is 1, so our GCF is 5a, and that goes right there. The rest of this is filling in the outside of the box. If there's a 5a there, what would have to be here? A. If there's a negative 15a there, what would have to be here? Negative 3. And then you can check by doing multiplication. 5a squared times a, sorry, I said that wrong. 5a times a is 5a squared. 5a times negative 3 is negative 15a. So we just found our dimensions of the rectangle, meaning the area equals 5a times a minus 3. This process is called factoring. Instead of writing it all multiplied out, we're writing it as a product of its factors. Okay. Procedure for GCF factoring, dividing something out. Put expression inside a box and separate its parts. So we're treating all of these as though they're the area. And our job is to find the width and the length. We're always taking out the GCF. What's my note here? Use parentheses for binomials and trinomials. Ooh, good note. Good note. I'm going to highlight that. Use parentheses for binomials and trinomials. And let's get started. So leave yourself a little bit of room when you go to write the box. You know, I'm leaving room so I can write on the top of that, okay? I'm putting a 10x here and a negative 25x squared here. Our job is to find the GCF. When I go to find the GCF, I do not want you putting the negative in the calculator. So follow along with me on the calculator, hitting math, going over to number, hitting 9, typing in the parentheses, 10, comma, 25, close the parenthesis. My calculator has found the GCF between 10 and 25. It is 5. They both have an x. The smaller exponent is x. There's my GCF. What would go on the top? 2. 5x times 2 is 10x. What would go over here? Here's where I take care of the negative. The negative comes up. 5 times 5 is 25, and I need an x there. So we've done the work. We just have to make sure we're expressing our answer as a product of two factors. So I am doing that. I do not like to box in my answers. I will highlight my answers just because there's going to be a lot of boxes on the page due to the factoring. There's my answer to number 1. Let's go to number 2. When we're asked to factor, we are supposed to think of this thing as the area, and we are breaking it up in terms of its width and its length. Okay, I don't have a number here, so there's nothing to type into my calculator to find the GCF of. If I want to put a 1, I certainly can. They both have an A, so I will use an A. 1 is the smallest exponent on A. They both have a B, so I will use a B. 1 is the smallest exponent on B. Okay, working backwards, thinking about what we would multiply to get A squared B. I would need to multiply that by an A. Working backwards, what would we multiply to get an AB squared? I would multiply that by B. My final answer, AB times A plus B. That is factored. I took this polynomial and I factored it. There's my answer. Okay, I think I'm going to do one more and then you guys are going to do the rest. I think the other one that I will do will be number 4, and then you guys will do 3, 5, and 6. Okay, 6, just to give you a heads up, is going to have 3 pieces. Okay, but I'm going back up to 4. That's what I'm going to do. I can already tell these are a little bit bigger, so I'm making my box a little bit bigger. 48x squared y plus, 36x cubed y squared. This is a good time to go to the calculator. Math, over to number, choice 9, type in 48, comma, 36, close that parenthesis, 12 is the GCF between 48 and 36. I see that they both have an x. X squared is the smaller exponent. They both have a y. Y to the first is the smaller exponent. Here we go. All right, so if you're not sure how to do this, you just type in your calculator 48 divided by 12, and that's the number that needs to go here. So I did 48 divided by 12, and I got 4. I can see that I have an x squared here and an x squared here, so there's no reason to put an x squared up here. I have a y, no x or y for this term. The only thing needed in that first spot is a 4. Let's move on to the second one. Plus, back to my calculator, 36 divided by 12 is going to give me 3. Now, I do need an x here because I only have an x squared and I need to make it an x cubed. So I need an x. I do need a y because I need to get a y squared and I only have a y sitting out there. Here's how I write my final answer. 12x squared y, parentheses, 4 plus 3xy. There it is. We've started. Ooh, I didn't mean to cross that out. I wanted to highlight it. What am I doing? We've started factoring, people. This is how we factor. You guys try 4, 5, and 6. We'll practice a few more of these tomorrow, but try those on your own and come in with those done and the back of homework 1. So you have a couple of things to do. You are going to finish those 3 problems, 3, 5, and 6, and you are going to finish homework 1. I will collect that tomorrow. All right, everybody, have a great day. Bye.